This is a demonstration of some of the methods and concepts that are useful when using a digital elevation model, a topography model in GIS to do a watershed study. A logical first step is to add a particular raster data set. When you use the Add Data dialog box to locate the digital elevation model, it'll have the icon that looks like a grid. And a raster data set, a DEM, is also called a grid format, and this is its particular symbol. Go ahead and say Add. It did not ask me to build pyramids, which it usually will the first time a data set is loaded. In this case, I've loaded this data set before. It's already created pyramids. A pyramid is an indexing data structure that allows much more efficient access and computation of a raster data set in a GIS. And it's almost always worth letting the computer go ahead and create pyramids. A small wait at the beginning saves processing time and response time much more later on. This is a data set, and it is a 1 degree by almost 1 degree. And I'll tell you why it doesn't go to a full square. It's a 1 degree by 1 degree ostensibly chunk of digital elevation data. If you look at the lower left where the coordinates are reported, it goes from 77 degrees longitude west to 78 degrees longitude west, and it goes from 43 degrees latitude, north latitude, and it would, if this were not a somewhat unusual data set, it would go all the way up to 44 degrees north latitude. The reason it chops off here is A, because it's not interesting, it's all open water up here, and secondly, it's also Canada up here, so the data set is truncated and it's not a true square or 1 by 1 raster data set. It just gets truncated because this is the border with Canada right here. This part still is Lake Ontario. It's our part of Lake Ontario, or the United States of America part of Lake Ontario. This is Irondequoit Bay and the Genesee River. And these are actually elevations. That's not a stream channel. That just shows the gorge and valley of the lower Genesee. This is the elevation, clearly is expressed in meters. The lowest elevation up here is 73 somethings, which would be meters, be converting from the feet elevation, which we usually we usually use to refer to lake levels. So that's the lake. That's a relatively boring topography. So where's our watershed, and what part of this is useful for our particular Allen Creek watershed? We can go ahead and add data, and the data to ask is Allen Creek boundary, Allen Creek boundary, polygon shape file, the symbol for that, and add, and there it is. We're fortunate. The watershed falls entirely within one standard chunk of DEM data, so we don't have to worry about merging and blending or anything. The next step would be to chop this large data set, large unwieldy data set, most of which is not relevant to our watershed behavior, chop it to the extent of our watershed. And that can be done by a tool called extract by mask. And that's just is the naming scheme. I don't care for it. And we'll double click on the tool and eventually it'll open up. While it's beginning to open up, I'd like to point out that this tool requires the Spatial Analyst extension to be activated, and it may or may not be activated on any new machine that you sit down at. So Spatial Analyst needs to be activated using the Customize Extensions menu. Shortly, the tool will open up. It seems to be dragging, but what it's going to do is that when I see the dialog box, it'll ask me for a raster data set, and I'll designate this one. It'll ask me for what I'm going to use as the mask or cookie cutter, and I'll mention this one. and it'll also ask me where I would like the result to go. Well, it's relatively straightforward to reclip or redo that, so we're going to skip the idea of how do you of saving this data set. We will create it, we'll let it go to a default location, which we don't know what it is. We'll use it, you can use it during the lab time, and then it can go away, and it can be recreated later. So as soon as this thing enables itself, we will be able to do the operation. So the dialog box finally opened up after a surprisingly long wait, and as I said, there's only one raster data set loaded. We'll choose that one as the input raster. As soon as it loads that, we'll have the chance to tell it what we would like the output, or the mask or the chop polygon to be, or the mask. And again, I'm not going to specify the format or the location for the output. We'll use whatever it gives us. We won't worry about it going away. But that's not normally what a professional would do. But since we don't need this beyond today probably, or it could be recreated, I can just leave it as that. We'll say OK. And I did see a flash of blue, which hints that it's actually doing the processing. It's a very big job. It does have to look over a very large amount of data and chop it back. Should be back to us soon. When it does, it'll ask if we would like to load the resulting data set into our table of contents so that it can be used. And I'd say that would be a good idea. Got the green check mark. Very happy with that. So what I'll do is I'll turn off the original grid. And now we don't see anything, and that might be disconcerting, but the reason is that the watershed boundary is opaque, and if I just maybe put a little bit of a red edge around it, that's good. As you know, there's a right click and zoom to layer, which helps us zoom in much better. So there's the raster data set chopped to the boundary of our watershed. Now the rest of this is relatively straightforward. I'm going to right click and ask for properties, which will allow me to do a symbology. A symbology. If I can recognize myself, well, maybe not, what the elevation 1, which is the most suitable palette or scheme for symbolizing is. I'm going to right click on this little arrow, down arrow right here, and turn off graphic view and get the names, and there's elevation number 1. So it's a good one. You can create your own, use a continuous single color shading. There's 100 of them, but we'll go ahead and use that one. And that symbolizes the watershed by colors. And now it's clear that these are the uplands. Here's the mid-range. Here's the incised topography in the downstream area, and here's the floodplain of the furthest downstream area of this. A very nice representation. Another tool that's very usable or very useful that you'll be using is called hill shading. And we're going to do hill shade again in Spatial Analyst and create a network is moving very, very slowly today. I'm going to pause my video and returning. I'm back, and we do have a hill shade dialog box. The input raster is not the original one. We only are interested in the extracted one that we just made. We'll let the answer go anywhere in particular again. We will take the azimuth and altitude, the sun positions, that are by default. They're quite usable for this part of the country. And we're going to, this is actually, even though there is some slope and some hills over there where our watershed is, we're still going to exaggerate by, we'll exaggerate by 30 to stretch the vertical direction and make it more prominent. And I'll go ahead and do that. It's processing hill shade down there. And there's the hill shading for the watershed. And even with a 30 multiplier for the vertical exaggeration, it still doesn't look terribly mountainous. It's now possible to really do something, and we can put the colors on top of the hill shade, which now totally block them out, but you can go ahead and ask for properties, display, and I think a good shot is 60% transparency, and say OK. And now we have colors on top of hill shade, which gives a nice visual representation of the topography of the watershed. And I can add another data set to enrich the picture. And I do not seem to have stream channels, and I don't want to start this over for the 80th time. So I'm going to go ahead and add something arbitrary, the tax parcels, to see if that, and that doesn't seem to help. If I were interested, perhaps I could go ahead and zoom in and see the relative topography where of the center points of tax parcels, but I don't think I'm too excited about this. Anyway, you'll be able to load a much more useful extra layer would be adding the stream network, and see all the channels that just fall, see the channels fall right in the valleys. And then by using the layout view, you can add title, space bar, and stuff. You can stretch this diagram out, etc. So that's the extent of the exercise, at least as much of it as I remember.